Hello, and welcome to the Introduction to FHIR and HapiFire tutorial for CS6440. I am Elizabeth Shivers. I'm a TA in the course, and I apologize in advance for the poor sound. Unfortunately, this was being recorded during the COVID-19 pandemic, and replacement microphones were not available. This video is divided into two parts, the first part covering FHIR itself, and the second part covering HapiFire. For this part of the video, we'll be discussing some core FHIR concepts such as resources and bundles, as well as performing simple queries. Note that we'll presume no foreknowledge of either FHIR or HapiFire, both of which will be explained in more detail momentarily. All demonstrations will be given using IntelliJ and Postman. You may use other options in place of these, but both are highly recommended, particularly as we'll be working in Java for HapiFire. We'll also be using some skeleton code for HapiFire operations during the second part of this video, which will be linked within the course. So, what is FHIR? FHIR is a data interoperability standard designed by Health Level 7, HL7, which stands for Fast Healthcare Interoperability Resources. Historically, many healthcare systems have lacked standards for the transfer of records between systems, complicating continuity of patient care and thus its quality, as well as increasing the workload on medical providers and support staff. FHIR is an attempt to address this issue by providing for a unifying standard for systems to communicate. Before moving further, it is important to note that FHIR has multiple versions with subtle differences, as it's still a work in progress being actively refined. Early versions, DSTU 1 and 2, are considered drafts for trial use, with the fourth version shifting to a release naming scheme and being appropriately labeled R4. R5 is the most recent version as of this video. The tutorial is based around version R4. Note that you will likely find yourself having to work with and support multiple versions of FHIR, so you cannot just assume the latest release is all you'll need to pay attention to in any case. HapiFire is an implementation of the FHIR standard in Java, as a community project led by the company Smile CDR. Here we'll be working directly with a Java FHIR client. We'll also be using a local HapiFire server for demonstration purposes as well. The setup of that is beyond the scope of this tutorial. Instructions for standing up a HapiFire server are provided in the course materials. As mentioned previously, the first part of this tutorial will focus on general concepts important to FHIR, with the primary topics being resources, bundles, and forming queries. FHIR is built around the concept of resources, as the name implies. Most things you might think of as part of a clinical record, including the patients themselves, are represented by these resources. Common examples include patient, procedure, observation, or medication. It is recommended that you look over the resource index on the FHIR specification site to get an idea of what all there is, though we've listed the most mature resources in the specification here for a general illustration of what to expect. So that you don't feel overwhelmed by the sheer number of them, however, you should keep in mind that you will likely be working with only a handful of the more obvious resources, such as those I listed a moment ago, on a regular basis. Additionally, keep in mind that many of these may be structural in nature, and thus something that you might get, say, as return from an operation rather than a resource you have to actively manipulate. For example, the operation outcome resource you see under level 5. Resources are commonly represented as JSON, and it is what we will be using here, though a number of formats are available such as XML. JSON is likely the most common. A resource consists of the resource type itself, metadata, circumstantial identifiers, a number of fields that form the core of the resource consisting of various data types or additional FHIR elements, and references to other resources. A patient resource, an extremely simple example of which is shown here, provides a good introduction to what a resource actually looks like rendered in JSON. Fairly straightforward. Note the presence of square brackets around some values and not others. As you probably guessed, some fields are single values while some allow for an array of values. The self-FHIR represents cardinality in its data structures and is explicitly laid out by the FHIR specification. For a patient, gender is a one-to-one relationship and must contain only a single value. Name is a one-to-many and can have a number of values, and so forth. let's take a look at the actual FHIR specification website at the patient resource page. It's a good habit to always keep the specification for the resource you're working with available while learning, so you can quickly reference the little details. To look at what we were just looking at a moment ago, notice the cardinality column, which clearly lays out what we just observed in the JSON, though with one added consideration. And a quick forewarning, I'll be using terms somewhat loosely here for explanatory purposes, so just keep that in mind. If you're listening to what I'm saying, like, well, that's not what that term means. I'm just trying to speak very generally. So instead of simply being one-to-one or one-to-many, the specification lays out minimum and maximum occurrences. 0 to 1 is functionally an optional one-to-one relationship, and that the resource doesn't have to include that element, but if it does, it can only have one of them. 1 to 1, such as you see down here, is a mandatory one-to-one relationship. And note that these are actually nested as part of another element, both with other and type as part of link, as well as with language as part of communication. So these are only required if the parent element is included, which these are optional, so these will not necessarily be in every patient resource. They're only mandatory in a patient resource that includes a link or a communication element. Now let's move our attention to the type column. Like the resource list itself, this might also feel overwhelming at first glance, but don't let it. If you look over the types, most are readily obvious what they are. Dates, booleans, integers, all simple data types. No extra FHIR-specific knowledge required. And for the rest, most of the FHIR data types are extremely simple in their own right, and only exist, of course, to enforce a uniform structure in the data, not add additional layers of complication where it isn't needed. So for now, let's take a look at the human name element, which, come over here. As we established, the patient has a one-to-many relationship with names represented by the human name type. If you recall our simple patient resource example, everything covering the patient's given name, family name, and suffix were all part of a single element of the human name type contained within the patient resource. This is why you don't see given, family, or suffix on the patient resource itself, because they're stored as part of the human name type, which you see here, and then of course this is nested into the patient resource. Now you can see that the human name type is represented in the same way as the patient resource itself and any other resource, and that it's just a series of nested elements. Just remember that this is not a resource in its own right. A resource stands independently even when it may reference other resources or even require other resources as part of its specification. A resource you can query for in return. A data type is standardized data that may be present in multiple resources and cannot exist outside of those resources. Human name, for instance, is used by a patient resource and a practitioner resource, among a handful of others. You cannot query the server for a human name and return a human name on its own, as it does not exist outside of the scope of the resource of which it is part. Which doesn't mean that you can't query a patient by their name or individual parts of their name by any means, simply that it is the entire patient resource that is returned, not just the name. And if you're wondering why a patient might have need of multiple names in their record in the first place, the use field gives you an idea why here. In order to maintain the continuity of records, it is important to be able to note previous legal names, including maiden names, as well as current preferred names or nicknames. And so FHIR has been very carefully designed so that patient records are far more thoroughly and consistently documented than many systems have it historically. This leads into a slightly more advanced topic in the very specific intended use for many elements of a resource, but as this is a topic worth driving home early, I'll take this moment to point it out. When working with FHIR resources, you should take time to read the specification closely, and the patient resource provides a prime example of why. The gender field here is a major potential pitfall when designing applications that is easy to overlook. Notice how it says explicitly administrative gender, and we'll take a detailed look at that in the actual detailed description list, if it would actually jump to it. I'll just find it here. So this field is intended to represent legal gender for, as it says, expressly administrative purposes which require it and should not be used as a clinical value. And you'll see that spelled out in the comments and definition on this particular page. A common example of this particular use case is transgender and non-binary patients whose legal gender may not align with their clinical needs in multiple ways. And so by using this as a clinical value, you may inadvertently cause medical error at some point. So you can see how paying attention to these little details about the resource can make a significant difference in providing quality care and knowing exactly what you're doing with these resources and these elements. And the gender field is one of the more documented in this respect, since it is a bit of a tricky one, based on how claims and things of that nature work versus actual clinical values. Returning to the patient resource again, let's go over a few other things real quick before moving on. First, notice down here on General Practitioner and Managing Organization that these are references to other resources, which it will state here in both type as well as have an icon that explicitly marks it. And under the type, it will also tell you the acceptable resource types that can be referenced under that element. The other major issue we need to address is identifiers, which you can see up here. Now, a resource has both a logical ID and an identifier element, and it's important to note the distinction between the two. So, looking over here at this defines the identifier element and gives you some general differences between logical ID and identifiers. So identifiers functionally is a unique means of identifying a patient, but that is not necessarily system specific to that FHIR store, to that particular resource, but rather the individual. Social security numbers, driver's license numbers, things of that nature. ID, on the other hand, is the logical ID of the FHIR resource on the FHIR server and uniquely identifies a specific resource. And coming back over to the patient, of course you'll see that identifier is defined, but ID is not. So FHIR is built on a hierarchy of resources, and patient itself is a type of domain resource. And so coming into the domain resource specification, you can see it provides a few extra elements, but still no ID, and it itself is a type of resource. So coming into the base resource definition, you will finally find the ID element, which all other resources inherit, and thus all resources may have a logical ID. Though do note that this is still an optional element, in that if you have a local resource or if you've just created a new resource, it doesn't necessarily have to have an ID. It only has to have an ID to be represented on a server. Let's now move on and look at bundles. When working with a collection of resources, you will most commonly use bundles. A bundle is a collection of independent resources, and in any scenario in which you are not targeting a specific resource, a bundle is what a query will return. I'll demonstrate more about this in the following section handling queries. Before we get further into bundles, take a moment to look at the documentation's reference to contained resources, which you'll see mentioned right here. And contained resources amount to incomplete resources for which an independent resource could not be created for some reason. This means they exist only within the scope of the containing resource, similar to any other element. As the documentation makes clear, contained resources are to be avoided whenever possible and used as a last resort. We won't be handling any contained resources during this lab, and it is unlikely you will run into them at all during this course, as they're more artifacts of real-world operating conditions, but you should be aware that they exist. Moving back to bundles, the section at the top of the documentation, up here, lays out nicely exactly what they are used for. While all are important uses, here we'll be focusing on the first, fifth, and sixth uses, which is returning resources from a search and using them for batch CRUD operations, as well as just as a collection. And scrolling down, you'll see the specification for a bundle laid out the same as any other resource, because a bundle is a resource in its own right. It's not a unique structure, it's simply a unique resource that is meant to contain other resources. So for the first use case of a bundle, let's look at an actual search using the FHIR test server. And I've just done a simple search for patients with a given name Robert. Now you'll see the resource type itself at the top, of course listed as a bundle, along with the usual metadata you might expect from, well, pretty much anything. Last updated, it'll give the bundle's logical ID, a few other important details which will go into more details in a moment that just help describe the bundle. So the actual results begin here at line 16 with the entry element. And entry is a collection of nested resources, and I'm saying nested resources, not just resources for a reason, which we'll show in a moment. And you'll see that's where the patients themselves begin, such as wherever this patient's name is, somewhere in here. So the patients themselves, any search results themselves are going to be nested in the entry element. And we'll show this in more detail using FHIR paths, which we'll introduce briefly. So I've copied our search return bundle into a FHIR path demo provided by HL7. So FHIR path is a navigation language with very simple syntax. It's similar to XPath if you're familiar with it. And it's a good way to just sort of browse around, look through resources, particularly larger resources such as bundles. And we'll do some simple queries here. And note that I have made some slight edits to our search bundle for display purposes. So if you just copy and paste what we have over here, you're going to get some display errors with the demo with these div elements. So to begin, on the right-hand side, you'll see the results of our FHIR path query, which right now is nothing. So starting out with bundle, we get our whole bundle back. And if you want just the bundle's meta element, simple as just the bundles, bundle.meta, and returning just that. Likewise, we can get last updated, which returns just the value, and so on and so forth. So let's look at bundle entry. Now, well, actually, I'll first point out, so as we said, the patient resources are nested within the entry element. So if you just go in and try to access index in the bundle as though the resources were stored directly nested in the bundle, then you're not going to bring up anything. But if we go down to bundle entry, we'll see it starts bringing back just our patients in the return there. And there we go, we have our first patient. And of course note that this is a zero indexing system, so typical indexing system. So you may notice something is a little strange here in that we actually have more than just our resource. And we also have this full URL element as well as the search element. So this is where we have to take it a step further and actually pull the resource itself from the first entry index. And a little bit of a quirk here is you can do this with this approach as well. And so this gets us to our actual patient resource, which we can then look through a bit more, such as name or name.use, and so forth. And if this had multiple human name elements, you would have to, of course, specify the index as needed. Now we're going to take a moment to point out the full URL element here inside the patient's entry. What this is basically the home of that resource on the FHIR server. As you can see, it's the resource type and then the logical ID. And so this is basically just sort of the single central place that defines this resource as a point of reference. And we're going to take a look at one more very important thing here with bundles. So you'll notice that the total count for the bundle is 245, meaning we had a return of 245 patients with a given name Robert. But if you were to scroll through these and count the patients, well, you're not going to see 245. So we can confirm this by using the FHIR count function, which shows that we only have 20 entries. So this is because bundles are returned in pages. The default page count, or the default count of resources on a page, is usually 20, as we can see with using this. And so our bundle is split into roughly 15 pages, or I'm not doing that math right, 13 pages. And we can get the additional pages using the link element. Now, the link element with the relation of self is the current page we're on, which you can see is just our basic search. And the relation of next is the next page in our bundle, which is going to be patients 21 through 40 in this case. And you can come over here and right here, and you'll see that this is in fact the next 20 resources, if you were to bother to stop and look. But you can tell more clearly based on the fact that it has this previous relationship now, which goes to the first page, whereas this one just has self and next. And then likewise for the final page, you'll see that there's no next, simply self and previous. And so navigating through pages is simply a matter of following these links and getting the next set of patients, or whatever resource you're working with in that bundle. So with our bundle full of Roberts, we just saw a simple query, and now we're going to look at queries in a bit more depth. So to get started, let's turn back to the FHIR specification website and look at the documentation for the RESTful API. So what we'll be doing is starting with a simple read and move through a few other of the main CRUD operations. But take note of the additional versions they have of some of these, such as, for example, vread, which allows you to get the specific version of a resource in its history, along with a few other similar sort of operations you can perform. But for the most part, we're going to be sticking to the basic read, update, and delete system. Create, read, update, delete, and search. To demonstrate the queries, we'll be using Postman and connecting to a local deployment of the Hapi FHIR JPA server, which has been populated by a few resources using Cynthia, for which there are tutorials provided for both of those, standing up a local Hapi server, as well as using Cynthia to generate test data available within the course material. And we'll start with a basic create resource. So, as you can see here, this is a post request to the server, and all we've done is specify our FHIR endpoint, the resource, and then we've added a format query parameter simply for the sake of completion. It's not always necessary depending on what the defaults of the server are specified as, but we're going to do it here just for demonstration purposes. So we've specified this as, note the underscore format equals application/JSON. And coming over into the body tab, we'll see our patient resource, which is just our simple patient resource from much earlier in the video. And we will use this to just send this to the server, and the server will respond and tell us that it has created our resource by providing the resource, its ID on the server, and then just sending the rest of it back to us. So we now have our patient stored on the server. And let's copy this ID and move over to the read patient query. So the read patient query is using get, and we're not bothering to specify the format or anything like that, but you can if you'd like, and there are multiple options such as XML. In addition to JSON, we're going to stick with JSON. So there's no body here because we're just doing a read. So let's pull this, and sure enough, there is our resource. So pay very close attention to the fact that the read is done by using the logical ID in such a way that's equivalent to the full URL that we saw in the bundles before. And this is a very important distinction from the way that searches work. So coming over here to search, we'll just search by that same ID. And this time for demonstration purposes, we'll also specify XML. So obviously we've got our patient back in XML, but the big thing to note here is that this is a bundle, whereas the read is a patient resource directly. So a search will always return a bundle. Doesn't matter if it's one resource or a million resources, it's going to send back a bundle. And this is a very important distinction to note for when you're navigating the returns from your request to the server. And let's get rid of that XML just for the sake of ease here. Just so that you know that you need to navigate this as a bundle when you're searching, even if you are searching by a specific ID and know that you are only getting a single resource back, whereas this will always just be the resource. And it's the same if you use observation, which I don't have an observation ID handy, so let's find one real quick. So let's come down here to search. And let's just search by observation, which is the observation, same. As searching by patient, you just change the resource type. And we have a good number of observations to work with. So let's just pull the first one, which is ID 106. So it's all the same. Doesn't matter what you're getting. You just switch up the resource type and then the parameters that you need. So we're going to run through the life cycle of a resource real quick, just to demonstrate, and we'll create a new resource for this. So we defined our resource here as a patient, Emily Simmons, and let's send it to the server. Get back our ID. Double check that our patient is here and ready to go. And sure enough, we have our patient. So let's now demonstrate the update operation, which uses put. So here we're again specifying our format and coming into the body. And notice, by the way, for body that if you're using Postman, you'll need to change it to raw in order to be able to paste in your resource or type in your resource and then change it to JSON here. So what we've done here is we've added an additional given name, which is the patient's middle name, and we're going to update the resource with this new middle name. Oops, I forgot to update the ID here as well. And I'll actually take this moment to point out the operation outcome that it returned. So operation outcome is a special resource that will give you information about errors, successful deletions, anything that doesn't have a resource to return. The operation outcome will be returned in its place, or not in its place, but as just a way to indicate that something has happened. So let's try this again, and sure enough, worked that time. And we'll come back and we'll read it one more time just to double check everything. And yep, there's our updated patient resource. So likewise, delete uses the delete request, as you might guess, and it's handled in the same way as the read and the update, which you just have the endpoint, the resource type, and the logical ID. And again, we see, because our resource has been deleted, we're getting back an operation outcome, which just tells us the results of the operation. And if we come back and try to read our deleted resource, again, operation outcome, and just gives us some information about the error, about the fact that this resource is no longer available on the server, and that it was deleted at this timestamp. So let's look at search in a little bit more detail. And let's change this back to patient just for simplicity's sake. So this is a search that hits that resource with no logical ID, and it returns a bundle of every patient on the server. And you can see here that we have 259 patients total on this server, and of course paging and all that, as you see here. So if we want to be more specific, we can search by a given name or any other element, but let's use given name for this example, and I've typed in a random string because I don't actually know the generated resources here. So we have 5 patients with the string mar in their given name. And we can actually find the name in all this, well, right here. You see, sure enough, Marcus. And this is just how you form the actual queries, the same as we did before with Robert. And it can be as complex or as simple as you like it to be. And of course, you can search by family. It's going to return patients with mar in the family name. Or you can just search by name, which is going to return patients that have mar in any part of the human name element, be it suffix, family, given. So we have a combined total of the 5 we had for given name, along with the 2 we have for family name. So as expected, there. And this is a little bit more of a complicated search that we're going to do that's going to return a procedure as well as the procedure, or the subject that the procedure is in regards to. And first, let's find a procedure ID that is in this current version of the server. So let's just go with this first one, ID 17. And you'll see that it will return a bundle that includes the procedure itself. And if you keep looking down here, you'll notice it includes the patient as well. Which, let's look for the start of the patient resource. So this is the patient ID 4 that is referenced here in the procedure resource. So what this does, this obviously allows you to search for specific procedures and return the subject of those procedures or any other reference resource. So if you want to search for a specific patient and you want to return that patient as well as their primary care physician, or if you want to search for a series of procedures and bring back a whole list of patients that have undergone these procedures, such as you were searching by a LOINC code or any other coding system or pretty much anything. And you can make this a little bit more complex if you'd like and just pull back every procedure and those procedure subjects, which is going to be a fairly large bundle, so we're not going to spend too much time there navigating that. And notice as well that this bundle has an ID of its own. So this allows you to reference this bundle and make sure that you're working with the same data. So that if, say, for example, somebody were to add additional procedures while you're working with this bundle, that way if you're going to go and pull the list again, you can go back to that original bundle you were working with rather than include that new data. Or there's a few other use cases as well. That's just a fairly basic one. And if we come over here and look at this, we can, oops, plug this into this query, which is get pages and get page offset. And this allows us to actually control where we are in the bundle, such as we are moving through the relation links, and also demonstrates the use of count here. So if we don't include count, we're going to get back the default of 20. If we do include count, we'll get back only 10 patients, which you can see is less than if we do Well, it's hard to tell there. Let's look at just one so you can tell that it's clearly a single patient returned, albeit a long one because it has all these extensions in it and identifiers. But this is the parameter that determines how many resources you're going to get back per page. Whereas offset is just how many pages you're offsetting. So if we have this and we offset by page, or if we have a count of 1 and we're doing an offset of 20, this is going to be patient number 21. And if we're doing an offset of 0, we're going to be getting back those first. Sorry, not patients, these were procedures, but the same thing applies. And that's really all there is to it. So these queries will be posted in a document alongside this video so that you don't have to worry about hyper-analyzing the structure from the video. So I recommend taking a look over that, and that will provide you a general example of how to form these queries. And then you can go to the FHIR specification website, and in that same original HTTP document we are looking at the start of this section, and it will go through the different search parameters you can use and provide additional details about using those parameters. And that will do it for this video. In part 2, we will be looking at the FHIR client and continue working with the local FHIR server.